channels, Insomnia from UnrealTek.net, a division of BlenderTek.com, and today we're going to look at the last major theory part of Unreal Blueprint networking through replication, which is functions. Function replication you may know as RPC, or remote procedure call. Variables usually drive something constantly, like say health or ammo count, going back to our original Counter-Strike shooter example. However, functions can be specialized and used for things that only need to be replicated once in a while at certain times and doesn't need to be constantly there and available over the network. What you'll find interesting is most of your networking will involve replicated functions in the end to create the actual logic to bring everything together. Before we get started, I want to remind everyone to post in the comments what they want to see in a networked multiplayer game, and then we can start making it in the next videos. So anyways, remember our motto, create your way, and let's get to it. First of all, let's look at some functions. So, when you think functions, you may think that we're thinking about functions when you hit the new function button and we create a new function. That's what you may think of. And while those may be used in your networking sometimes or a lot, when we're talking about networked and replicated function, we're actually talking about custom events. So if we are to create a new custom event, you can see that when you select it in the details panel, we have replicates, not replicated, which is by default, multicast, run on server, and run on owning client. And we also have, if we select a replicated function type, the ability to make it reliable or not, which we'll get into later. So this is what we talk about when we call about functions, because a function in the programming sense, and this applies to blueprints too, is just a collection of statements. So, you know, it might be a print string followed by a switch authority followed by another print string. You know, it's just a collection of statements put together that can be called at any time, and it might even have arguments. So a custom event really is a function, and that is what we will be using when we talk about function replication, because when you make a function, you don't have replication options in it. However, functions can be called within custom events. Anyways, moving on. What I've done here is set up a new spinner so that on event begin play, it creates a dynamic material instance and then it sets it to green. And then what happens is we have a new overlap box, a collision box, and when something overlaps it, it goes into the switch as authority node, and then it calls a function. You can see target is BP spinner function rep, reliable, and it's replicated to all meaning all clients and the server if the server calls it. So that's something to take notice of. If I was to call this from the remote, it wouldn't get called at all because it's saying only if server. And we'll get into that more in a few minutes. So it goes on the switch has authority, and the server then calls this setRed multicast function, which is this right here. So it's a custom event called setRed multicast, and it replicates in the multicast function, and it's reliable. And what it does is it turns the cube red. And then when we end the overlap, we do the same thing. We go through the authority and the server sets green multicast. So it's the same thing, it just sets it to green. So first of all, let's see what happens when we play as just one player. So as we can see, it's set to green. When we overlap, it goes to red, and then it goes back to green when we leave. So let's see what happens when we have two players. So we'll get it set up so that we can see it. we can see our server's view, so we can see the green cube back there, and I'm going to play as the client. So when I walk up to it, it turns red for both of us at the exact same time, and when I leave, it turns green for both of us. So that is replicating just fine and dandy. However, something interesting, if we were to play it through this graph and hit play and go through the client, let's see if we can get this into view here. So I'll get the switch has authority, I'll get the again overlap into view if possible. It's kind of hiding, but we will see the bottom one, the end overlap. So you can see it's firing off, but then when I leave, you can see it's also firing off because we're simulating on the server. So only the server is firing this event off, not the client. Like I said, if we set this up so that it checks, and if we are a remote, as in a client, you will see that it does not fire off on the server. However, it's still happening on the client, and that is, again, because of locality. The spinner is not owned by anybody. And if we were to set it up again so that we can see, and I go over here, as you can see, however, though, well, it's working on the client, it's no longer working on the server. So, it's only calling it remotely. It's only calling it on the client side. So what's happening is it is executing the logic on the client, however, the server isn't seeing it and the server isn't replicating it to all because it's not the server that's getting having the function called. But going back to our original logic, that makes a lot more sense, where we just check if we're the server, and if we are the server, we replicate it to all, and everything was working fine and dandy. It turned red and green as it should. Let's talk about multicast. So, like I said, we have these multiple options: multicast, run on server, and run on own client. It says multicast here. Replicates this event from the server to everyone else. The server executes this event locally too. Only call this from the server, and you can see why, because if we called it from the client, then the server doesn't see it, for example. So multicast, as the name suggests, casts it to multiple people. So basically, when we do the server check, and if we are a server, what's going to happen is it basically sends it out to everybody. So the server comes along and goes through the switch, and he sees this function that says set red multicast. So he comes and he executes it, and he says, I'm the server, so I'm going to execute this functionality right here, this node, the set vector parameter value. However, I'm going to tell every single client to execute it as well. So the server is replicating this functionality, this function, two nodes technically, to every other client. And as you can see, it works without a hitch. Both our client and server were able to see the changes in color. So using the multicast option is the most beginner friendly, obviously, because it just kind of works. And you may ask yourself, why don't we just use it all the time, since it seems to work all the time? But it's not optimized at all. So I highly suggest against it. In fact, you will see very few multicast functions in a well done replicated network setup. However, you will see them in in-game actors that are not owned or spawned in by any specific player, controller, character, pawn, or any other pawn derivative, and rather are just actors in the games that require replication, like let's say the bomb areas in Counter-Strike maybe, which might be owned by the game state or something, and not owned by a player. So you might see something like this on, say, our spinner, which is owned by the game state and not being spawned in or anything by a player controller, and it is not a player in itself. And so not only is multicast not optimized, it also has some safety limits, if you will. Essentially, it only allows you to call it a few times per frame to avoid network overload, because it's sending it to everyone no matter what, whether they need to see it or whether they need to execute it or not. And so the Unreal Engine 4 netcode, I believe, if you were to execute this, say, 5 times in 33 milliseconds at 30 frames per second, it's going to start ignoring some of these calls because you'll start overloading the network. And so Unreal has a little safety switch in there to prevent you from executing it too many times. Let's talk about this reliable check mark 2. If we uncheck reliable on both of these, you'll see the function changes. The big reliable in caps goes away. Let's compile and save it and play. And if we go ahead and do this, you will see that it works exactly the same as before. So what is the purpose of reliable? And reliability really is what we're talking about here. Why is that checkbox there? Basically, if the reliable check mark is checked, it makes sure in the netcode underneath all this that eventually the logic in your function will make it to where it's told to go no matter what. Even if you're downloading every episode of My Little Pony or whatever, it's going to make it there eventually. Whereas if we set it to unreliable, as in have it not checked off, there may be instances if there's lots of network traffic that it won't get to its destination. And so things that are very gameplay important, again we go back to what is gameplay important, or what is important to gameplay and not. Stuff that's gameplay important, you would want to be reliable. So if this was something like remove health, we would probably want that to be reliable so that we don't accidentally have, you know, someone get shot and there's lots of shooting going on and then that their health doesn't go down. So that would be something that you would want to have reliable. But cosmetic events, such as changing the color of this box, unless that means something in the game, we don't have to set that to reliable, and thus we can free up some more bandwidth, if you will, for our network traffic, because it's just cosmetic. If the client overlaps it and one player doesn't see it, if it's not gameplay essential, it's not going to ruin the game. On the other hand, however, remember variables. If we take rotation rate here and set it to replicated, you'll notice there is no reliable checkbox. So what that means is we consider variables always reliable, and thus they might use up a little more network traffic than functions. So you can optimize your game a little bit by deciding, should I use a replicated variable to do my functionality, or can I put it into an unreliable function without ruining the gameplay at all, without risking it at all? So again, this comes into importance for things that are cosmetic, like bullet tracers, explosions, and so on. And that goes back to whether it's gameplay important or not. If it's gameplay important, we might want to have it checked off as reliable. And if it's just a visual change, it won't break the game if it doesn't happen on a client. This gives us the ability, like I said, to optimize our game. And one more interesting thing to remember on top of all of this is that variables kind of just jump in the river of network bandwidth and float downstream till they're picked up. And that might take a while depending on the latency of clients and the server, whereas a function, reliable or not, will do the same thing, but he's going to take a speedboat right down the bandwidth river super fast until that function gets picked up or hits a dam and blows up. Thus, we consider functions immediate dispatching. This is an example of the multicast setup, ignoring many calls per frame. If you're calling it, if you're calling a function, it's immediately gonna try to get called on other clients, a replicated function that is, immediately. Whereas a variable just kind of gets set out in the traffic and it'll get picked up eventually, but it might take a while. So that's why multicast functions can really make your game slow down a bit in the network sense, because not only are they trying to get to every single client, they're trying to get there immediately no matter what. And variables will take their sweet time, so to say. It's still very fast. I mean, pings are getting into the single digits almost nowadays, but they still won't immediately try to be replicated to other clients, whereas a function will be, even if it's not set to reliable. So that's one little thing on top again, is immediate dispatching versus non-immediate dispatching. So some of the other options we have, which I won't get into detail with until we start building a little multiplayer game, because they're kind of tougher to exemplify. But we also have run on server and run on owning client. So if we set it to run on server, you can see that it says replicated to server if owning client. So if we come through here and we do the switch has authority, and it says we're the server, and it comes across this, it says replicated to server if owning client. Well, if we're not the owning client, that's not going to get executed. And if we come through here as a remote, as a client, and it says replicated to server if owning client, we're the client, so we're going to replicate that back to the server. So that's what that means. And if we switch this to run on owning client, it's sort of the opposite way. We come through, we say, okay, yes, we're the server, and it will replicate to the owning client if we're the server. And so basically what this means is run on server is a request from a client to run a function on the server. So basically what that would mean is this executes on server. It would obviously not be setRed multicast, but let's just say it was called setRed executes on server. What this would mean is basically the client is saying, hey server, can you please execute setRed? Is what that means in a nutshell. So a good example might be say client number 4, player number 4 saying, hey, I captured the flag, server, can you please update the scoreboard and maybe play the flag moving up on the flagpole? Server, since I'm not allowed to do that since you own it all in the back end. Now this can only be used on actors that have a net owner, which means again that they are a player controller or they are owned by a player controller. So this run on server and run on owning client is not going to work on our BP spinner unless we say spawned it in through a player using a player controller. So going back to our example, basically if we had to capture the flag game, let's say the server spawned in a flag, let's say this was our flag, this box back here. If player 4 came and captured the flag, he would execute that run on server log. The player's gonna say, okay server, you spawned in this flag at the beginning of the game, so you own it, and now that I've captured it, can you please update the scoreboard to say that player 4 owns it, and please move it up visually as well. And thus the server will execute it. And if we go to the other side, run on owning client, you'll see again replicated to owning client if server. Again, obviously means that it is the opposite. It's a request from the host or server to run a function on a client that owns a certain actor. So we could even go back to the same example, and it might work out like player 4 says to the server, okay, I captured the flag and I owned it because I spawned one in. Can you please update the scoreboard? And I'm also gonna make the flag move up since I spawned it in and I own it and I can do that functionality. And the server will say, okay, sending that stuff out now, but you need to run the function called play flag animation because I'm the server and I don't want to handle your cosmetic junk now that you own the flag in a code sense. Now, of course, we probably wouldn't allow players to own the flag actor in a capture the flag game, but it gets the idea across. And this option as well can only be used on net owner set actors. So again, if the flag was just a game object and wasn't spawned in by the client, he wouldn't be able to do the example I just tried to explain. So these are a little bit more complicated. It takes some examples of where they're used to start understanding them. So that's why showing off multicast is much easier for an example like this. So like I said, start throwing out some ideas in the comments about what you'd like to see in a networked game example, and we will start setting up some actual real logic for a networked game. Whether it's in the first person template or we could switch to a third or whatever. Throw out some examples and we'll get to it. In the next video, if I get some time before then, I'm obviously going to do a health and damage setup because that makes sense. We should probably give our players some health and the ability to hurt players when we shoot them with our little yellow balls, and also some sort of way to set up our doodads replicated. I think would be interesting. Being able to, I don't know, maybe set their colors from the main menu, or I don't know, when they get shot, have them change to a different color or something like that. So that'll be what I will get to in the next video, as well as any things that you guys would like to see that you think would be cool or would like to learn. We will start working on, and we'll go through all the different function replication, variable replication. We'll start going through game states and player states and game instance, and going through how to set up an actual fully networked game. So that is all for now. Thanks for watching from the team here at UnrealTek, a division of BlenderTek.com. If you enjoyed this video and learned something, please like it, and don't forget to subscribe for more videos. As well, we now take donations. If you look in the description, we're on social media on the links on your screen. If you disliked this video for some reason, please tell us why, so we can continually improve them based on your community input. So we'll see you next time, and remember, create your way.